Hello, everybody. My name is Torsten Lodderstedt. I'm from Yes.
Hi, everyone. My name is Kristina. I work at Microsoft as Identity Standards Architect.
And we are going to present today about our work on OpenID for Verifiable Credentials. This is work being done at the OpenID Foundation in cooperation with Decentralized Identity Foundation, ISO, and ETSI. So let's start with the fundamental question. What is decentralized identity, and how can OpenID for VC help people to implement decentralized identity solutions? If you take a look onto the traditional model, the federated model, you've got an IDP that maintains the data and also provides a cryptographically protected assertion to the party that wants to consume the data. It's typically referred to as a relying party or a service provider. There are other terms for that. With the decentralized model, there is a third entity added to the picture, which is the wallet that acts on behalf of the user. And the data is not directly sent from the what's now called the issuer to the verifier. Instead, the user installs the credentials in the wallet and then at her discretion can present those credentials wherever she wants and also in the combination she wants. And there are a couple of benefits, and that's why people are so excited about decentralized identity. First of all, the issuer doesn't know where you're going to present your credentials, so it greatly increases privacy, but it will also allow for portability of the information. But there are different other aspects to that. As I stated yesterday in the talk about the IDAS, the European Commission, for example, wants to fully go towards replacing physical driver's licenses with digital driver's licenses. And there is a lot of potentials in that because it's cheaper to issue digital credentials, it's faster. You can just issue the credential in the very moment where you sign up for something without waiting for the postal service to deliver the plastic card to you, right? And it's more secure because you can use cryptography to make sure the data is integer and is authentic. And you do not need to rely on physical properties of the credential to make that happen. And third, once you have the credential digitized, you can use them in the physical and in the online world. So we've got the universal representation for credentials that can be used in both places, right? What drives me, for example, nuts is we already have digital credentials on our smartphones. For example, a vaccination certificate. But right now, I can't present that online. I don't understand that, right? So I believe that's one of the fundamental breakthroughs that decentralized identity brings us. We can use those credentials wherever we want, and without the issuer being involved in that thing. We have been looking into providing a layer of interoperability on the protocol level. Why is that important? So let's take a look onto the architecture picture. And just imagine there are hundreds or even thousands of wallets, issuers, and verifiers. So if every one of those, for example, issuer, creates its own protocol in its own language, it would be a real mess. That's why we believe having protocol or having interoperability on the level of the protocol for credentials is crucial. But we also have identified a couple of challenges while working on that stuff. So first of all, it's super easy to build a new protocol. Everyone can do that. The harder part is to get it secure and to get it simple. I could also say to get it right. And so what we decided is to build our work on already widely used protocols, namely OAuth and OpenID Connect, because they are understood. There is security analysis, even formal proofs for their security, and they are well known to be really simple to use. Second, if you attended the previous session here, you already know there are so many credential formats in that space, right? So alone the representations, we have more than 15. And if you combine that with the different ways to represent keys and revocation methods and so on, it's incredible. So there is no clear winner yet. Perhaps we will settle on a couple of formats, but right now, that's not the case. And that's why we believe it's important to design a protocol that is independent of the credential format. So people can use the same format, the same protocol, even though they use different formats and different applications. And they can also use, in the same transaction, probably, credentials in different formats. So like the example that I gave before, you can use you have an MDoc, a mobile driver's license, an MDoc format, and an educational credential, which is perhaps JSON-LD. What we also learned, not everyone likes DIDs. Believe it or not. So there are other ways to represent keys, and there are a lot of different DID methods. So we believe an exchange protocol should not be tied to one specific method. It should be extensible, combinable, customizable to be worked with different ways to resolve keys. And then the last point, and that might be the hardest one, when we started with OpenID Connect, almost all deployments were pretty closed. So the entities knew each other. Over time, that changed, for example, with the advent of open banking. So there suddenly were a couple of IDPs and a couple of relying parties that were talking to each other and relying on other parties to introduce them to each other. With decentralized identity, that challenge is bigger by a multitude, right? So I guess no one would expect a certain wallet to register with all the issuers that are available on this planet, right? So there needs to be other mechanisms to establish trust. And we believe that the credential exchange protocol should be flexible with respect to the trust management mechanisms that can be used to establish trust between the verifier and the wallet and the issuer. Say hello to OpenID for Verifiable Credentials.
Yay!
So we have 3 core protocols that are composing the family of OpenID for Verifiable Credentials. On the left-hand side, on the interface between the issuer and the wallet, it's OpenID for Verifiable Credential issuance. It's a simple API OAuth protected that is used to create credentials. And on the right-hand side, we have 2 protocols for 2 different purposes. OpenID for Verifiable Presentations is obviously the protocol to present credentials. Self-issued OPv2 is used to authenticate the user using key material that is maintained in the wallet. And since someone asked after the last session, the user could also use that to convey self-asserted claims. Because the whole material that is signed in self-issued OP2, where version 2, is signed with key material under the control of the user in the wallet.
OP stands for OpenID provider.
Who didn't know that? Okay. We are really pleased that our work has been adopted around the globe. So there's massive traction around that. And to start with, on the left-hand side, the European Union right now is updating the eIDAS regulation around digital identity and trust services. And OpenID was selected, or OpenID for VC was selected for issuance, online presentation, and online authentication as a technical underpinning of that whole thing. And then NIST has plans to implement OpenID for VP, which is also part of the ISO standards around MDL and MDoc, in a reference implementation and wants to test it. And on the right-hand side, and I think it was the first profile, and Kristina demonstrated it last year here at that conference, interoperability, true interoperability between different entities, namely Ping, Microsoft, IBM Spruce, Auth0, and Digital, based on the Decentralized Identity Foundation's JOT VC presentation profile. That was really amazing. For the first time to see different wallets from different providers, not based on the same technology, but independently implemented to really interact with each other. And there are a couple of other places where the protocol is used today. If you want to know more, just talk to us. And there is open source available. And right now, it's really exciting because my feeling is every week there's a new open source library implementing parts of the protocol family. And this list isn't even complete because there's so much happening right now. And if you are implementing a library, an open source library in that space, please let us know, right? We want to share that information with other implementers. And I'm also excited to share with you that the Open Wallet Foundation has yesterday, or the Technical Advisory Council of the Open Wallet Foundation has yesterday approved the idea to put forward a task force that will try to facilitate and support implementation of open source for OpenID for VC over at Open Wallet Foundation. And with that, I hand over to my partner in crime, Kristina.
Thank you, Torsten. So from here, the second part of our presentation will tell you more about the protocol, how we were designing it, what extension points we were building, and after that, in the final part of the third part of the presentation, we'll walk you through if you want to build a tech stack based on OpenID for VC as protocols, like what choices you have to make, like what you'll have to combine. So this is, we're getting into the second part. So first, let's start with the credential issuance side, which was on the left-hand side when Torsten presented. So at the basis, it's an OS-protected API. So what this means is if you already have an existing OS infrastructure with authorization servers running, what you do is you add a new endpoint which is protected using your existing OS mechanisms, but issues credentials. And one thing we really care about is supporting various security levels. So to be able to have the highest security, that's so you can meet various regulatory requirements, with standard constrained tokens, replay protection, and all those, but also be able to have the basic implementation so you can bootstrap and start running pretty quickly. Also, various business requirements. Each company has their own business processes, right? And so make sure that interoperability is ensured while each company is able to accommodate their existing processes using the technology. So for example, some issuers would like to perform in-person identity proofing when issuing a credential, right? Legit. Because when we're turning digital credentials into physical, that's a part where impersonation is highly likely to happen, right? You're binding the credential to a wrong person. But also, there are cases where it's okay to do it remotely, right? Remotely, I upload my PDF or selfie or whatnot. So various scenarios are supported. And also, really important, user experiences, right? Depending on if you have a strong relationship with a wallet, you can have pre-existing relationships, so user just downloads an app and just click, and gets a credential, or you want the user to scan, QR code, whatnot, support it. And finally, going to the trust, and this is also what's really important in MDL use cases, for example, issuer being able to check the wallet's capabilities, like how the wallet manages the keys, who's trusted, what crypto suites, whatnot, and vice versa. The wallet can discover dynamically what credential issuer is capable of issuing, and basic protocols as well. So really basic protocol flow. This is the basics, right? We'll dig in deeper from the next slide. So this is what we call wallet-initiated flow, where the wallet first sends a request to the issuer saying, hey, I want you to give me this credential. Issuer authenticates the user, gets user consent, and returns the access token to the wallet. So this is the OAuth protection part of the protocol. Next part is what's mainly extended in this protocol. Wallet sends now a actual credential issuance request saying, hey, this is the credential I want to issue. And what's important here is so that credential can be presented online, there are different key binding, holder binding mechanisms to make sure during presentation it's a legitimate presenter that's presenting to you. So that's where issuer is willing, so for example, if it's a cryptography based, here the wallet will send the key, cryptographic key. This is what I control, please bind the issued credential to that key, and then magic happens and credential is being returned. They get basic, this is the very, very basic flow. Yes? Is there a question?
I was just wondering if you could talk about, is the credential issued more of a bearer, meaning it can move around between wallets, or is it linked to that particular wallet?
Great question. So that's, from protocol perspective, we're not limiting that, right? So we'll talk about it later, but if you want high assurance credential, it is possible to bind the credential to a hardware-bound key, right? So user cannot move it between the wallets, to your point, between devices, let's say. But it's also possible to bind the credential to, not a hardware-bound key. So in that case, it is potentially, you could move. So from protocol perspective, you're not limiting that. So both are possible. Oh, the left side hand is a bit cut off. I'm sorry. So there are two flows we have. So far, I've mentioned only one flow, where you already have an existing authorization server. You already have, oh, thank you. Always good to have tech people in the room. Yeah, so this is this first flow where there's already existing, let's say, database that you have about the users, which you're using to do your usual OAuth or OpenID Connect or any other flow. And you want to also have a smooth transition towards decentralized identity. So you're trying to turn that data into a verifiable credential. So for example, if some of you in your infrastructure has a user info endpoint, you can use the same data you return from user endpoint and return it issue it as a verifiable credential using this flow. So on the left-hand side, I was trying to illustrate that there are multiple ways to initiate a flow. So for the previous example is the wallet just sends a request to the issuer, right? So user experience is more of like user downloads the government application, everything is already pre-configured. I click get my digital tax document, get my digital driving license, get my digital marriage, whatnot, and wallet knows what to do. But that's not always the case, right? So that's where there's also an issuer-initiated flow, where issuer, the data structure is defined by the protocol. How you want to communicate it to the wallet using QR code or deep link or whatnot is we're leaving it up to you. But let's say, for example, user went into the office, government office, did an in-person identity proofing, and later on, user is getting a QR code in the physical mail, user scans it, and that starts a flow. That's also possible, right? And yeah, so long story short, the wallet displays to the user, hey, do you want to get credential from issuer.com? And the user clicks yes. That goes to the web browser. The center square is the issuer's interface, right? So that's where issuer has to authenticate the user. Again, from the OAuth perspective, you can do whatever you want. Here, example is password. You can do any other mechanism you're currently using, OTP, WebAssistant, whatnot. And again, gets user consent, authorization to issue the credential, user's yes, and credential gets sent to the wallet. Ta-dang. So the second flow is when there is, let's say, no authorization server that exists, which are honestly a lot of first cases that we see in the market. So that's where, so in the previous flow, when you authenticate the user, you know which data to get from whatever you keep the user's data, let's say database, right? Like you know what to get. Here, you don't have that, so you collect the data up front. That's more of that, the physical identity proofing example. I physically go, the issuer collects the data, and they have it, and later it tells me, hey, here's your QR code, go retrieve it. The wallet scans it, clicks proceed, and behind the scenes, it's magic, it's directly being issued. What's happening behind the scenes is that data that was pre-collected is being turned into a credential. So I hope I'm not overcomplicating, but all I'm saying is there are 2 ways to authenticate the user: add the authorization server, but even if you don't have it, you're covered, you're good to go. There's a flow where you can authenticate the user before you start the flow. So 2 ways to authenticate the user. So now we're going to presentations. So that was issuance, now it's presentation, right? Privacy, very important. A lot of choices we're making in the protocol is to ensure user privacy. Again, trying to support various security levels. So the highest assurance scenarios are supported. The bit more lower scenarios are also supported to meet wider range of use cases, different user experiences. Here it's more about user storing the credential on the same device where it's interacting with the verifier or not, what we call same device cross-device. You can also present multiple credentials in one go, not just one by one, but also multiple. And you can also combine credentials from multiple formats, like Torsten already mentioned. And various wallet deployment models. Like, we're not limiting you to only native app wallets. If you need to do cloud wallet, that's supported. B2B use case, for example, right? Or if you want to do a browser-based wallet, because that's sufficient for your use case, great, also supported. So yeah, I just said it, but native app, cloud wallet, browser wallet. This is the same device presentation, so it's kind of more of a basic OAuth redirect-based flow as a starting point to think about. So user goes to verifier's website, that's a square, and verifier says, hey, do you want to present the credential with a wallet? The user gets redirected to the wallet authenticates the user. Again, how the wallet authenticates is up to the wallet. It can be username, password. Here it's biometrics, it's fingerprint. And then wallet gets user consent, authorization. Users, yes, I'm okay sharing this credential with this verifier. And verifier is like, great, thank you. Please proceed with the user experience. This is a cross-device presentation, and this is new. Yeah.
How do you do wallet invocation? Meaning that people may have more than one wallet.
Sure.
So there was magically the wallet is invoked.
Right.
How do you solve that wallet invocation problem?
Yeah, so there are multiple mechanisms in the market, right? So again, the protocol is not married to one way to do it. There are ways to do custom URL schemes, use uplinks URL universal links, and ways also to use in-wallet camera to invoke the wallet. So either one of those were used, and the wallet was invoked.
Wallet invocation.
Yeah, that's a wallet invocation. If the
How does the user pick which wallet they want?
We do not invent anything that is not already in the market here. All we do is there's a URL that you use to invoke the wallet. How that URL is picked is outside of the protocol design.
Okay, thank you. No, that's the question.
Good.
Thanks. So now we're to the cross-device. The verifier, in this case, is interacting with the user at the desktop. The verifier asks, hey, user, I want to register you. Here's a QR code. User uses their wallet. In this case, let's say it's a smartphone, scans the QR code, gets a request. Here's authentication. Oh, the PIN is a security protection for this cross-device mechanism. And also the sharing the identity credential. And then back to that desktop, the desktop experience gets refreshed, the user presents the credential happily, the flow continues. The features of entire OpenID Verifiable Credentials suite, right, for issuance and presentation. We know the name says Verifiable Credentials, but we're not talking about only W3C Verifiable Credentials. You can do MDocs in CBOR format to find an ISO over OpenID for VP. That's absolutely supported, right? Is Deja defined in IETF, also supported. Anoncrats defined in, I don't know where the home is now, but supported. So again, does not require the use of blockchain at all. No coins, Jeremy. And it's an open standardization process. So we really, really care about your implementation. So please implement and give us the feedback. And we're pretty agile and transparent about why we incorporate or why not. And we're getting to this deeper, but it's modular and flexible. So that's because we're trying to cater for different use cases and for different legislations. Like, it might look easier just to have one stack, which is perfectly tailored for one use case, but in the long term, there are certain obstacles you'll face when you try to extend it for other use cases, and we're trying to prevent that. So that's where you would need to know which parts you want to extend how to meet your use cases and your regulatory requirements. And which is, it's irresponsible to say just you need to know. So we're actively helping the implementation community to define these profiles and help to kickstart this interoperability journey amongst the implementers. And for now, we only covered these 3 protocols. We have new additions to the family coming. So the key keyword is omitted, but it's openly for file presentations over Bluetooth. Whenever we talk about this to the government, the question is, great, but we also want to enable sending verifiable credentials offline, right? And there's still a lot of countries where feature phones are the main phones, or the data plans are very expensive. So, and in fact, we do already have running implementations of OpenID for VP over Bluetooth. So come talk to us if you want to see the demo. So as much as we are extending OS whose security analysis has been formally done, we do want to be very, very careful with how we're extending. So the formal security analysis on all this flow is being done. So hopefully next year we'll be able to report back to you, is there any vulnerabilities found? If not, and how we address them and whatnot. We are actively working with our OpenID Foundation's amazing certification team to give you the self-certification tools so you can easily check if you're compliant or not to guarantee interoperability again. And the high assurance profile is a piece we'll dive into in the last part of the presentation is, so for example, we mentioned that EU Digital Identity Wallet Architecture Reference Framework shows these standards. And for example, this is where it could potentially be used, where we're saying this is a government level stack, which could mean the highest level of assurance. And with that, we're going to dive into that last part.
Thank you very much. I would like to add what Kristina just said, is we are a very transparent community. If you want to take a look into the security threat analysis and the trust model, it's documented, right? You can download it from the public webpage of the OpenID Foundation and can also come up with your own assessment. And hopefully, if you figure out we made a mistake, please let us know. Let's talk about the high assurance profile. This is one concrete instantiation. Shall I go there? Okay.
As you want.
This is one concrete example how the protocol suite is instantiated for a certain context. So other people could do other profiles. Right now we are focusing on one profile. And just to recap why there is a need for profiling. In the end, it's the other side of the flexibility medal, right? So we have a profile that is credential format agnostic, so you can use that in different scenarios. But that also means it's a framework, right? In the same way as OAuth 2, for example, is a framework. And since we want to really achieve interoperability, truly binary on-the-wire interoperability that is testable, we need to make decisions for certain contexts. And that's what we call profiling. And what a profile does, it defines a couple of things. Basically, they fall in 2 categories. One category is, what do you need to implement, or what must be implemented? Which features of the protocol? The protocol itself does not have a mandatory to implement section. It just describes the options, and people can pick what they implement. In a profile, you need to make sure that, for example, the verifier can rely the wallet implements a certain flow. And that's why you need to determine what is mandatory to implement for which party. And the second point is, you need to define, and here you really need to decide, what credential format you're going to use, what key management mechanism you want to use, and so on, as long as it is relevant for the protocol, right? This is the place and this is the time where you need to decide. And you also need to decide what custom scheme to use for wallet invocation. Because the assumption is if you're going to use a custom scheme or a app link, there can be multiple wallets behind that scheme. right? So calling a custom scheme also means you associate an assumption about what's the capability on the other side. So this is why it's really tightly coupled to a profile definition. The high assurance profile of OpenID for VC with SD-JOT obviously combines OpenID for VC with SD-JOT. Who of you has never heard about SD-JOT before? I should have asked the other way around. So, okay. So what I want to achieve is, and we started the work at the last IAW, is interoperability across parties while preserving privacy and being able to fulfill security requirements, especially put out by regulations. So for example, hardware-based or hardware-based holder binding for credentials is our utmost importance for personal identity credentials. But also the ability to authenticate the verifier, to be able for the wallet to really display to the user what party the data is released to, right? To make sure you know how you're going to sue if something goes wrong. And there are a couple of projects, jurisdictions, and folks interested in that profile. And we believe we can really achieve a certain degree of interoperability on a global level with that. So we will contribute that work, or we are contributing already actively. So I got up 4 o'clock in the morning today to attend a expert group meeting today. We contributed to eIDAS. The Californian DMV is considering to implement the profile. It will be the basis of, or hopefully will be the basis for OWF projects. There is work going on at OpenID Foundation to, in the end, define a certain type of credential that will do what today the user info endpoint does in OpenID Connect, right? To facilitate a way forward for people interested in this kind of credential. We as a company are working in a research project in Germany. It's called ID Union, and it has been mostly a Hyperledger shop previously, where we decided to go forward and adopt a new technology stack. And this, one could say that a lot of the experience and the insights that underpin the definition of that profile is informed by work we have done around credential formats and protocols and all that stuff. But we're going to use that going forward. You want to add something? Okay.
Yes. Is Deja 3C stands for Selected Disclosures with JOTs. We're going to dive into that deeper. DMV is Department of Motor Vehicles, and in America with TSA for domestic flights, the requirement is to use ISO MDocs, right? But if you want to cover a lot of use cases, if you want the same driving license to be used for age verification for various online services, if you want to capture those verifiers, one of those incentives, California is one of the first Department of Motor Vehicles who are also experimenting and issued that driving license in multiple formats, including VCs and SD-JOTs. So they can cover both regulatory for TSA use case, but also other use cases, just to kind of, yeah.
Thank you. And there is another project that will put, or there is a project that will put our profile to a test, which is the GAIN project. There is a community group at OpenID Foundation that in the last 1.5 years has set up and implemented a sandbox where different existing identity networks and identity providers were integrated using a federation infrastructure. Idea was to show and try to figure out how existing identity networks can be connected to each other to increase the reach of each of them, right? And leverage global reach. And I'm one of the co-chairs of that work, of that community group. And we recently decided to now do the next step and also try to figure out whether we can leverage the data that sits in those IDPs to decentralized ecosystems through the issuance of verifiable credentials using this profile. So going forward, in the next couple of months, we will see an extension of that sandbox with the ability at least to issue verifiable credentials into wallets. And I mean, they will also be presented somehow. And if you're interested in that and want to be part of that, and want to contribute, please talk to me. And then we've also the Japanese government interested in using the profile in a project. Do you want to say something? No, that's okay. Cool.
They're interested.
Okay, so then let's go to the real meat. There are 3 core protocols: SIOP, OpenID for VP, and OpenID for VCI. And we somehow need to fill all the extension points that are defined in the spec. And just to give you an idea, we have to define the custom scheme that is used to actually invoke the wallet. We have to define the crypto suites that are being used. And we have to define the credential profile that is being used by the protocols. You might wonder why you don't see the crypto suite in the presentation and issuance protocol. The reason for that is it's all in the credential profile. Because the credential profile itself then defines what crypto suites and what key management mechanisms are being used by the particular credential profile. And with regard to OpenID for VP and VCI, one also needs to define what mechanisms are being used to authenticate the verifier towards the wallet and to authenticate the wallet towards the issuer. So we need to fill those. And first of all, we decided to go with verifiable credentials based on SD-JOT as the credential format. And we use what we call the wallet attestation scheme. It's basically using a JWT which is key bound so that the wallet instance can receive kind of a credential and use that to authenticate directly to an issuer. So as Kristina pointed out, we are aiming at high and highest privacy levels. So the idea is that even if a wallet provider has a backend, that thing doesn't need to go through the backend, right? The wallet, the native wallet on the user's device can directly talk to the issuer, which is the shortest and most privacy-preserving path. And that's why we need this kind of key-bound assertion to authenticate towards the token endpoint of the OAuth authorization solver. It kind of sits on top of the existing assertion flows, the pre-existing in OAuth, and adds that ability to really do a proof of possession so the issuer can make sure that's really a legitimate wallet. And we also define the custom scheme. It's called HAIP, like High Assurance Interoperability Profile.
I'm terrible at naming. If you're going to come up with a new one, I'm going to buy you a bottle of wine. So please help us.
And that refers to the custom scheme
the
only?
Custom scheme, yeah.
Okay, so framing is important. For the issuer key resolution, you see, we were unable to just come up with one solution. So what we have right now in the profile is a web-based key lookup mechanism and X509 certificates. And the reason for that is we first of all want to come up with a profile that has really broad adoption. And there's always a fine line between being super simple and having really broad adoption. And we're trying to hit the sweet spot. And the web-based mechanism in the end works pretty much like OpenID Connect Core manages keys today. So you've got a URL in the credential, and you use a well-known location to look up the key material, potentially a key ID, and then you can check the authenticity and integrity of the credential. That's pretty simple, right? On the other hand, there are requirements to have long-term validation, really elaborated trust management and all that stuff, and to utilize existing infrastructures. And that's where X509 kicks in, right? One example is in the European Union, eIDAS version 1 has a really sophisticated infrastructure for signing assertions in a way that they can validate it even 10 years later. After all the certificates have have expired. And that very much relies on X509 and trust lists on all that stuff. And we wanted to support those use cases as well. We have not decided yet what is mandatory to implement for what party. And we have a big fight about that. So if the issuer is supposed to support everything, if the wallet is supposed to support everything, so that's the kind of negotiation that is going on if you build such a profile. So if you have an opinion on that, please let us know. And the last is the crypto suits. This is basically, as far as I understand, ECDSA with a certain curve.
Yeah.
Yeah, okay. And SHA 25065 for the fingerprints. So that's basically the decisions we made for setting up and customizing this instantiation of the profile. I think we wanted to...
8 minutes left, maybe the questions.
8 minutes left?
Yeah.
Okay, then I will skip those. That's cool, right? We want to just save time for giving you the opportunity to ask questions. Huh? Say it again, please.
There's a lot of good information that you would like to learn, so we're not able to cover it in a copy of the day.
Yeah.
I think
As far as I know, it's distributed over through Identiverse. But if you want, just...
I think it's in the app, but also it's highly likely to appear on Torsten's LinkedIn within the next 24 hours. So I highly recommend going to his LinkedIn.
Yeah. Otherwise, just drop us a message and we send you the material. So as we say, we are open, transparent.
Or maybe Twitter.
Do you still use Twitter?
I do.
Okay, cool. So just some more information about the credential format, because right now there is an SDJ spec, and what we are working on is also a spec over at IETF that defines how SDJ is used to define verifiable credentials. I already explained the key management mechanisms. What's also in the package is a status list mechanism that works well with JOTs and SDJs, because the status list mechanism, even though it's influenced and inspired by status list 2021, uses a JOT to represent the status list, whereas status list 2021 uses a JSON LD-based credential. And that would force implementers to use different kind of tools, right? To verify the credential and to verify the status list. And that's why we are doing this for JOTs, and we actually also do this for CWT. And that's how such a credential would look like. Do we also have the encoded version? The decoded version? No, we don't.
Yeah, for SDJ, Brian did a great presentation yesterday, so it should be uploaded in the Identiverse as well. So for details, highly recommend going there, or again, drop us a message.
And what the profile does, it, for example, defines exactly what claims need to turn up in the credential. That's the difference to the more general purpose SDJ specification and also the VC SDJ specification. We are saying, okay, you're obliged to have those in the credential in order to allow the verifier to actually verify the credential. I think we skipped that.
Those are the questions.
Huh?
Those are the questions.
I didn't see that. Oh, over there. Go ahead, please. No, can you speak up, please, because we can't hear you.
So my question is actually regarding, SDJs can be used in the verifiable presentation normally because, the privacy comes in the picture. Why is it necessary to use also the issuance process? Because I think we are also using in the issuance process also use the SDJs, or is it just used in the presentation? Can you repeat the question?
I haven't answered. Can you repeat it?
The question is, are you using SDJ only during presentations or during issuance? And so the way selective disclosure JOTs works is, in traditional GWS, there's one signature over the entire JSON, right? That's why if you modify something inside the payload, you break the signature, right? That's why the current mental model is you can't selectively disclose anything inside the JWS. How SDJs work is inside that issuer-signed JOT, you have hashes, right? So you don't have the actual plain text personal information, right? That is passed alongside things called disclosures. So if you have both the hash and disclosure, you can know the plain text, right? So that when the issuer issues, issuer does issue a JOT to answer your question, which means issuer sends this issuer signed JOT and all of these disclosures, so the wallet can know all the claims actually being issued, right? What happens during presentation is, depending on what is being requested and what user consented to actually disclose, the wallet sends the entire issuer signed JOT without any modifications. You can't modify that or you're going to break integrity. And the disclosures of only those claims that the user consented to disclose, right? So yes, you're using SDJOT both during issuance and presentation. Does that answer your question?
Yeah.
Okay.
Yeah, it answers, but I don't understand why it's used in the issuance process, because that's my...
I mean, okay, the question is why do we use this in the issuance process? Okay, who in your opinion should create the SDJOT? The wallet? The wallet is not the authoritative source of the data. That's the point, right? The issuer is the authoritative data source of the data, and that's why the issuer needs to create the SDJOT. I mean, it's the whole point. If we could create a selectively disclosable JOT in the wallet, we would not need SDJOT. I mean, JOTs in OpenID Connect allow selective disclosure because the JOT is on-demand generated. This is done for the three-party model or the issuer, holder, verifier model, where the issuer spits out something that sits in the wallet and then is at the discretion of the user used someplace else. That's why we need that the selective disclosure capability in the credential, right? Because the wallet can't do it. Does it answer? Excellent.
Yeah.
Go ahead. That's the last one, I guess.
Two short questions. The attestation-based client authentication, is that being done in the IETF or in the OpenID Foundation?
That's we are preparing a draft for IETF.
Okay.
So the general plan is everything around SDJOT goes to IETF because IETF is JOT land.
Okay, so no draft on that published yet?
We're planning to publish an individual draft within the next week or two. Yeah. And expect the work related to vanilla JSON/JOT-based third-party model work, a lot of what we mentioned, expect that to happen in ITF. So it's not going to be W3C.
And then the OpenID for VC for high assurance profile, is this in the Connect working group or is this happening?
For the time being, yeah. We are preparing to spin up a new working group around OpenID for VC, and then the work will be conducted there.
Okay, but it's in Connect now?
Say it again?
It's in Connect working group now?
Yes, it is in Connect working group. We have a special call or two special calls on that, the so-called SIOP special calls, yeah, where people gather around this set of specifications.
OpenID Foundation updated their website, which is awesome, but within that process, some of the data is still being updated, so you might not be able to see it on the web page in the next week or so. But just ping us, and again, I'll just send you the URL.
Okay, thank you very much.